All right, chapter 15, problem 57. This is a dampened oscillation problem, and the damped oscillator decreases the amplitude by 3% during each cycle. Right? What percentage of the mechanical energy of the oscillator is lost in each cycle? Well, let's take a look at the equations for a damped oscillator. Right? And this is cosine omega prime t plus phi. Okay, so that's the equation for the amplitude of the damped oscillator. So what they're talking about decreasing by 3% every cycle is that term right there, e to the minus bt over 2m. Now we don't know any of these things, but we do know from one period to the next that goes down by 3%. So, and if we look at the mechanical energy in an oscillator, right, 1/2 k x sub m squared, and then this term is e to the minus bt over m. So not quite the same term, right? I mean, this term e to the minus bt over m, that out front is e to the minus bt over 2m, right? So how do we figure out how much the mechanical energy goes down? If we know e to the minus bt over 2m goes down by 3%. Okay, so first is to recognize that e to the minus bt over 2m, right? That's where we are. If we take that whole thing and we square it, what do we get? Right? This whole thing squared, well, that 2 multiplies the bt over 2m, and so that squared is the e to the minus bt over m. All right? So after one cycle, e to the minus bt over 2m becomes 0.97 of what it was. That's a reduction of 3%. We square that, and we get what? 0.97 squared, 0.94, 0.94, 0.94. So, roughly speaking, each 3% decrease in the amplitude of the oscillation results in a 6% decrease in the mechanical energy. All right, mechanical energy is down by 6% because the amplitude is down by 3%. All right, that's it for problem 57.